Hello everyone, my name is Dr. T.S. Kurne, Department of Statistics, Rajeshri Chhatrapati Shahu College, Kolhapur. In last lectures, we have seen that the expectation of mean sum of square due to the treatment. In this lecture, we have studied the expectation of mean sum of square due to the error. So similar method is used like mean sum of square due to the treatment. So first, we write the formula for sum of square due to the error. This is the formula. Here we want the value of yi dot bar only because mathematical model contains yij. So only quantity calculated is yi dot bar. So first write the mathematical model of CRD. Then we want the quantity only yi dot bar. So here how to convert it? It is into yi dot bar. Summing over j, it is yi dot and divided by ri, so get yi dot bar. So now this equation is summing over j and divided into ri, we get yi dot bar. This quantity here, this sum is converted into ri, so ri get cancelled. Now mu, here also same ri, so here half I and here the same like yij, so it is converted into epsilon I dot bar. Now the equation 1 becomes, we substitute the yi dot bar value into this equation, so wait, and yij value is this, so we equation 1 becomes sum of square due to the error is double summation of mu plus alpha I plus epsilon ij minus mu minus alpha and minus epsilon I dot bar. Here mu get cancelled, alpha get cancelled, only remains epsilon ij and epsilon I dot bar. So this is the, we consider a minus b bracket square. So expand this, a square minus 2ab plus b square. And now taking the expectations of this sum of square due to the error, we want mean sum of square. First we take expectation of only sum of square. So this equation becomes taking expectations. Here we have taken the expectation in inside. First we taken the summation over inside and then taken the expectation on inside. Expectation apply on only on epsilon ij. So this is the variable, all other values are constant. So it is first one by one we calculate the value taking the double summation epsilon ij epsilon I dot bar. So first we simplify the epsilon I dot bar is taken as a sum over I and epsilon ij taken over the sum over j. This sum is remains as same, this quantity also remains same. This value is converted into ri into epsilon I dot bar by simplification, and then ri is taken as outside, this both are same, so it is square. So this quantity is converted into this. So then finally expectation of sum of square due to the error is substituting after the value of this expectation of double summation epsilon j square minus 2 into this quantity ri into summation over I epsilon I dot bar square plus final quantity summation over I j epsilon I dot bar square. Then simplifies this equation taking the expectation inside. So double summation is outside, expectation on epsilon ij square. This is a constant quantity, expectation applied on the epsilon I dot bar square, and this whole both summation is outside taking the expectation of epsilon I dot bar square. So we know that the values of all these expectations. So see that epsilon ij is normally distributed, we know that mean 0 and sigma square. So finally we get converted because it is previously seen. So epsilon double dot bar is with mean 0 and sigma square divided by n variance, and therefore the variance of epsilon double dot bar is sigma square by n. And what is the formula of variance? It is expectation of this variable minus expectation of that mean bracket square, and we know that this mean is 0, so put it is 0. So expectation of that epsilon dot variable bar is sigma square by n. Similarly, we calculate the value of epsilon I dot bar. So what is the distribution of epsilon I dot bar is it is normally distributed with mean 0 and variance sigma square divided by r. So directly we finally taking the values, because not taken a variance, because any variance the expectation value is 0, so directly expectation of epsilon I dot bar square as a variance, because mean is 0 also, so directly value is sigma square divided by ri. Then the equation 2, this equation 2, putting the values of all these expectations in this equation number 2, we get expectation of mean sum of square due to the error is double summation sigma square, because here is epsilon ij square and minus 2 into ri summation over I sigma square divided by ri plus double summation over ij sigma square divided by ri. By simplification like that, this both summation is converted into n, then sigma is square minus 2 ri it is as it is, this summation or as it is, sigma this whole quantity as it is. Here this terminology based on only I, so j summation over j is converted into ri get cancelled. So first we write the ri, then get cancelled. So after that, in last step, this is this n into sigma square. Here the ri get cancelled 2 times, summation over I means v, here is v written as a v into sigma square, because I get cancelled, the sigma square quantity is constant, so write the summation over final, so write it is as v. Here also ri get cancelled, so sigma square is constant value, so summation over I is from v, so it is write as a v into sigma square. So finally this is the minus 2 times v into sigma square plus 1 times, it is write as a minus 1 time. So finally the value of expectation of sum of square due to the error is n minus v into sigma square. Here we want expectation of mean sum of square. So for both sides we divide the degrees of freedom of error. The degrees of freedom error is n minus v. So we get mean sum of expectation of mean sum of square. So here also divided by n minus v. So n minus v and n minus v get cancelled. Then we get expectation of mean sum of square is equals to sigma square. Here it is a no any biased quantity. Finally we get the expectation of mean sum of square is a sigma square. So without any condition, expectation of mean sum of square due to error is an unbiased estimate of sigma square. This is the proof. Under H0 it is follow, but without any condition, the mean sum of square due to error provides an unbiased estimate of sigma square. Thank you.